In this video, we're going to be looking at binomial probability distributions. What we're going to be doing here is defining what a binomial probability distribution is, what are the requirements of a binomial probability distribution, and some methods of calculating binomial probability distributions. Okay, so in this case here, let's first define what a binomial probability distribution is. Okay, here a binomial probability distribution it results from a procedure that meets all of these requirements. Okay, and there are 4 different requirements for a binomial probability distribution. Number 1 is this, that the procedure has a fixed number of trials. It has a fixed number of trials. And a trial, by definition, is a single observation. Okay, so the procedure must have a fixed number of trials. Has a fixed number of trials. Then second, the trials must be independent. And what do we mean by independent trials? Independent means that the outcome of any individual trial will not affect the probability of the other trials. Okay? That's what we mean by independent. And then the third is this. Each trial must have outcomes classified into 2 categories. And usually we refer to them as success or failure. Okay? And sometimes you may have acceptable or defective or survived or died. Those are considered to be outcomes that are classified in 2 categories. Because it's either going to be a success or you're going to have a failure. One or the other. And then the 4th requirement is this, that the probability of success remains the same in all trials. Okay. So these are the 4 requirements for a binomial probability distribution. You must have a procedure with a fixed number of trials. Then your trials must be independent. And then each trial must have outcomes that are classified in 2 categories. Either success or failure, for example. And the probability of success remains the same in all trials. Alright, now, the next thing I want to talk about are 3 different methods of calculating a binomial probability. Okay? So here we have 3 methods for finding a probability that deals with a binomial distribution. One method of calculating the binomial probability distribution would be to use the binomial probability formula. Okay, and we use this binomial probability formula, which is going to be p of x is equal to n factorial divided by n minus x factorial times x factorial, and that's going to be multiplied by p to the x times q to the n minus x. Okay, now I need to explain what each one of these variables mean. Okay, the n, of course, is your number of trials. The x, that's the number of successes. The p is your probability of success, and that's usually going to be in one trial. And q is going to be the probability of failure in one trial. And I do need to mention that q is always equal to 1 minus p. So if you know what p is, the probability of success, then the probability of failure can be found by subtracting 1 minus p. Okay? So one method is using the binomial probability formula. And I'm going to kind of alter this a little bit, because that n factorial divided by n minus x factorial times x factorial, that looks like a combination type formula. So if I was to rewrite this in an alternate way, then probability of x would be this, ncx. Because this formula is the combinations formula. And that's multiplied by p to the x times q to the n minus x. Okay. Now that's one method of finding a probability distribution and the binomial probability distribution using that binomial probability formula. The second method is using technology, which is what we're going to be using in these examples here, because that's the best preferred method of finding binomial probabilities. So here we'll be using technology, step number 2, or the second method. Okay, and for those of you who are taking my class, we know that you can use StatDisk. Also, Minitab can be used. Microsoft Excel does binomial probability distributions. StatCrunch is another software that you can use. Also, SPSS. This is more likely used in graduate school, but you can use that to find binomial probability distributions. Now, the one that we're going to use, that I'm going to be using in this video, will be the TI-8384 Plus calculator. Okay, and there are other computer software that's out there that you can use to find binomial probability distributions here. Okay. And then the third, now again we won't be using this one either, it's going to be table A-1. And for those of you who have the Trello text, this is what table A-1 looks like. And this is only part of it. But here, table A-1 is very limited. Okay? So we won't be using that in this particular video. So you won't have to worry about table A-1. I just want you to see what it looks like. Okay? and table A-1 represents binomial probabilities. Okay. Now, the best way, an effective strategy for finding binomial probabilities, use computer software or the TI-83 or 84 plus calculator if it's available. That's the best way to do this, which is what we'll be using in this video. The second option, use table A-1, and then the third option is to use the binomial probability formula. Okay, so we'll be using the TI-83 and 84 plus calculator in these examples. And we'll start with this one. Alright, in this case, assume that a procedure yields a binomial distribution with a trial repeated n times. And you're going to use the binomial probability formula to find the probability of x successes given the probability p of success on a single trial. And in this case, your n is 21, x is 18, and p is 0.75. Okay? So, like I stated before, we will be using the TI-83 or the TI-84 plus calculator. Now, the command that you're going to have to use is this. Binom PDF. Okay, and I'm going to show you how to access the binomial PDF function on the calculator. Alright, in this case, you're going to have to press the second key. It's going to be the blue key if you have the 84, the yellow key if you have the 83. So it'll be second, and then the vars, which is right next to the clear key. And you should get the DISTR menu, which is the distribution menu. Now what you're going to have to do is press your down arrow key to find the command that says binom PDF. And here it is. Okay. That's binom PDF. Okay. You'll highlight that and then you're going to press enter. Now, if you have the TI-84 plus calculator, you're going to see this. It'll have trials and then P for your probability of success and then your X value, and then you're going to paste that. Okay, in this case here, your N, that's the number of trials. That's 21. Your N is 21. So you'll type in 21 and then press enter. Your P, that's going to be 0.75. You just type that in and press enter. Your X value, your X is equal to 18, so you press 18. Or type in 18 and then press enter. You're gonna and it's gonna highlight the word paste. So you'll press enter and then you're gonna press enter again to get your answer. Now, if we were to round this off to 3 decimal places, it would be 0.117. So in this case here, binom PDF, and then we go ahead and write this out as NPX. Your N is 21, your P is 0.75, and X is 18. And that's equal to 0.117. Okay, so here, the probability of 18 successes given that the probability of 0.75 in a single trial would be 0.117. And I also want to show this if for those of you who have the earlier 84s and the TI-83, because this one's a little bit different. Okay, you'll still press second and then vars for your distribution menu, and then press the down arrow key to find binom PDF, and then press enter. Now it's going to come out like this. Give you binom PDF and then left parentheses. N goes in first. That's 21. And it's going to be separated by a comma. The comma is right above the number 7 key. So you'll press the comma And then in this case here, your P goes in second, that's 0.75, comma, and then your X goes in last, which is 18. And then hit enter. Well, close the parentheses and then hit enter. You'll see that you'll get 0.117 as your answer. Okay? So pretty much the format I can give you that would be this binom PDF. You have N, comma, P, comma, X. For those of you who have the TI-83 or the earlier TI-84 Plus calculator. Now, if you have the newer TI-84 Plus calculator, you won't have to do that. It'll just tell you, enter the number of trials, then press enter, then your probability of success, you'll press enter, and then your X value, you press enter. Okay. Alright, let's look at the next example. This one has the table already given to you. So here you're going to refer to the accompanying technology display. The probabilities in the display were obtained using values of n is equal to 5 and p is equal to 0.791. In a clinical drug test, 79.1% of the subjects treated with 10 milligrams of the drug experienced headaches. In each case, assume that 5 subjects are randomly selected and treated with 10 milligrams of the drug. Find the probability that more than one subject experienced headaches. Is it reasonable to expect that more than one subject will experience headaches? Okay, so now we're finding a probability. Now, if we were to write that in symbolic notation, it'll be x is greater than 1, because it says more than 1. So in other words, it cannot be exactly 1. So what we're going to need to find is the probability of exactly 2 experiencing headaches, the probability of exactly 3 experiencing headaches, the probability of exactly 4 experiencing headaches, and the probability that all 5 experience headaches. Okay? So we're just simply going to add these probability values together. The probability of 2 was 0.0571, plus the probability of exactly 3 was 0.2162. For 4, it was 0.4091. And for 5, it will be 0.3097. So all we have to do there is just add those decimal values together. You'll get 0.9921. So the probability that more than one subject experience headaches will be 0.9921. Now, is it reasonable to expect that more than one subject will experience headaches? Okay. Now, the answer to that would be no. Okay. And the reason for that would be because that if you add the probability of one person getting a headache and the probability of no one getting a headache, it'll be less than 0.05. And that would be unlikely. Okay. Okay, let's look at this next example here. A brand name has a 60% recognition rate. Assume the owner of the brand wants to verify that rate by beginning with a small sample of 4 randomly selected consumers. And here we want to complete parts A through D below. In part A, what's the probability that exactly 3 of the selected consumers recognize the brand name? Alright, now let's look at what we have here. Our P, which is the probability of success, will be 0.60, because 60% recognize the brand name. Our N is 4. That's the number of trials. And we're dealing with, in this case, exactly 3, so we have x is equal to 3. So here we want to find the probability of exactly 3 of the selected consumers recognizing the brand name. Here we use the binomial PDF function. Okay, so n, well, npx, n is 4, p is 0.60, and x is 3. Okay, and I'll rewrite that format again. Okay, now in this case here, using our calculator, we press second and vars for the distribution menu, and then we use our down arrow key to find binomial PDF, and then the number of trials in this case was 4, so that's your n. Okay, and then press enter. Your probability was 0.60, so that's 0.60, and then press enter. Your x value in this case was 3, so we enter 3, and then press enter to highlight paste, and then press enter again. And then finally press enter again, which will give you 0.346 if we were to round that to 3 decimal places. So the probability of getting exactly 3 selected consumers that recognize the brand name would be 0.346. So that's part A. Now part B is the probability that all the selected consumers recognize the brand name. So now we're looking at x is equal to 4, because that's all the randomly selected consumers. So here, the probability that x is exactly 4, here we use the binomial PDF command, and n is 4, p is 0.60, this time x is 4. So in this case here, second and vars for the distribution menu, and then hit the down arrow key to find binomial PDF. The number of trials was 4. The probability was 0.60. This time your x value is going to be 4. And then highlight paste, pressing enter, and then press enter again. To 3 decimal places, it will be 0.130. So the probability that all the selected consumers recognize the brand name would be 0.130. Now part C was the probability that at least 3 of the selected consumers recognize the brand name. Now in this case, at least means greater than or equal to, and at least 3 is greater than or equal to 3. Well, in this case here, all we have to do is add the probability that exactly 3 recognize the brand name, and the probability that 4, which is all 4 of them recognizing the brand name. Now, back in part A, we found out that the probability of exactly 3 was 0.346, and the probability of exactly 4, back in part B, was 0.130. So add 0.346 to 0.130, you're going to get 0.476. So the probability that at least 3 of the selected consumers recognize the brand name will be 0.476. Alright, now part D. If 4 consumers are randomly selected, is 3 an unusually high number of consumers recognize the brand name? Alright, in this case here, 3 is not going to be unusually high. And the reason for that is that the probability that exactly 3, or at least 3, which is going to be 0.476 that we got back in part C, that's bigger than 0.05. So here we can say that the probability that x is greater than or equal to 3 is bigger than 0.05. Now, had it been less than 0.05, then it would be unusually high. Okay, here's another example. In a region, there is a 0.7 probability chance that a randomly selected person of the population has brown eyes. Assume 13 people are randomly selected. Complete parts A through D below. Here we want to find in part A the probability that all selected people have brown eyes. Okay, so that means our N is 13. That's the number of trials. Your P is 0.7. And in this case here, we're dealing with all selected people having brown eyes. So that means X is equal to 13. There's that 13 people, and we're telling us if all 13 of them have brown eyes, what is that probability? So here, that's where we use the binomial PDF command. Binom PDF. N is 13, comma, P is 0.7, and X is 13. So here, I'll clear all this out. In this case, it will press second and vars. For the distribution menu, then we hit our down arrow key to find binom PDF. Press enter. Your number of trials is going to be 13. That's your N. Your probability, which is going to be your P, 0.7, and enter. Your X value is 13. And then hit enter to highlight paste, and then hit enter again. Then you'll hit enter again. Let's see, to 3 decimal places, that would be 0.010. So the probability that all the selected people have brown eyes will be 0.010. Okay, so that's part A. Part B, find the probability that exactly 12 of the selected people have brown eyes. So now this time, X is equal to 12. So we want the probability that X is equal to 12 this time, using the binom PDF command. So our N is 13, your P is 0.7, this time X is 12. So in this case here, second and vars. And then we scroll down to find binom PDF, which is this command right here. And then the number of trials, that's your N, that's still 13. Your P is still 0.7, but this time your X value is going to be 12. Then enter for to highlight paste, and then hit enter, and then enter again. This time it'll be 0.054. So the probability that exactly 12 selected people have brown eyes will be 0.054. Okay, part C. We want to find the probability that the number of selected people that have brown eyes is 11 or more. So this is what we're trying to find, the probability that x is greater than or equal to 11. 11 or more. We know the probability for 12, and we know the probability for exactly 13 from parts A and B, but we need the probability of exactly 11. Okay, so off to the side, I'm going to do the probability of x equal to 11. And that's where we use the binomial probability distribution command. And in this case, our n, that's your 13. P is 0.7. This time, x is 11. So, using the calculator, second in bars, hit your down arrow key to find binomial PDF. Number of trials is 13. The probability of success is 0.7. This time x is 11. Then hit enter 3 times. So it would be 0.139. So the probability of exactly 11 would be 0.139. Okay? And I had to find out what the probability of exactly 11 is, because in this case, when you're finding the probability that x is greater than 11, you have to do this. The probability of getting 11 exactly, plus the probability of exactly 12, plus the probability of exactly 13. And the probability of exactly 11, I just found it out to be 0.139. The probability of getting 12 is 0.054. And the probability of getting exactly 13 was 0.010. I'm getting these from the answers of parts A and B. So if we add these numbers together, you should get 0.203. So the probability that the number of selected people that have brown eyes is 11 or more will be 0.203. And then part D, if 13 people are randomly selected, is 11 an unusually high number for those with brown eyes? Well, if you take a look at this, that answer would be no, because that's bigger than 0.05. Okay? So we can say no, that the probability of x is greater than or equal to 11 is greater than 0.05. Okay? Now, had it been less than 0.05, then it would be then 11 would be an unusually high number. Okay? And I have one more example that I need to cover in this video. A TV show, Lindsay and Tobias, recently had a share of 20, meaning that among the TV sets in use, 20% were tuned to that show. Assume that an advertiser wants to verify that 20% share value by conducting its own survey, and a pilot survey begins with 18 households having TV sets in use at the time of a Lindsay and Tobias broadcast. And in this case, we want to find the probability that none of the households are tuned to Lindsay and Tobias. Okay? Well, we're dealing with 18 households, so that tells me N is going to be 18. And my P, it says 20% watch the show, so that's your probability value of success, 0.20. Now in part A, we want the probability that none of the households are tuned to Lindsay and Tobias. So here's x equals 0. So we want the probability that x is equal to 0. And here we can use the binomial PDF command. Your n is 18, then P is 0.20, your X is 0. So using our calculator, we press second and vars, and then we go down to Binomial PDF. Select that one. N is the number of trials, this time it's 18. Press enter. Your P is 0.20, then press enter. Your X value this time is 0, and you're going to press enter. To highlight, paste, and then press enter again, and then press enter again to get your answer. So in this case, the 3 decimal places, it will be 0.018. So the probability that none of the households are tuned to Lindsay and Tobias will be 0.018. Now part B is finding the probability that at least one household is tuned to Lindsay and Tobias. Okay, now think of this. At least one. It's going to be the complement of the probability of none. Okay, and we found that the probability that no one watched the show, that's 0.018. So at least one is going to be this, the probability of X greater than or equal to 1. That's going to be the complement of the probability that no one watched the show. That's probability of X equals 0. And we found that out to be 0.018. So if we do 1 minus 0.018, you're going to get 0.982. So the probability that at least one household is tuned to Lindsay and Tobias will be 0.982. So this is where we use it says at least one, the complement of that will be the probability that no one watched the show. Now part C says this, find the probability that at most one household is tuned to Lindsay and Tobias. At most. Okay? We first got to find the probability of exactly 1, because at most means less than or equal to. Okay? So that means one person, exactly one person watched the show, or exactly no one watched the show. So we need the probability of exactly 1, which means we need to use the binomial PDF function. N is 18, P is 20, this time X is 1. So using the calculator, we got second and vars. We scroll down to Binomial PDF. Number of trials, N is 18. Your P is still 0.20, but this time X is going to be 1. And then hit enter again, and then hit enter a third time. So it'll be 0.081. So the probability of exactly one person watching the show will be 0.081. Now from that, we can find the probability that at most 1, which is, in symbolic notation, X is less than 1, less than or equal to 1. And that means this, the probability that exactly one person watched the show, and the probability that no one watched the show. Well, the probability of exactly one watching the show, we found that out to be 0.081. The probability that no one watched the show, we found that out in part A, that's 0.018. So if we add 0.081 to 0.018, you're going to get 0.099. So the probability that at most one household is tuned to Lindsay and Tobias is 0.099. And then part D, they ask the question, if at most one household is tuned to Lindsay and Tobias, does it appear that the 20% share value is wrong? And the answer, why or why not? Okay? And by this case, in other words, that answer is going to be no. Because it's not, doesn't, that 20% share value does not appear to be wrong. Okay? Because that is likely for that to happen. And the reason for that is, if we look at the probability that x is less than 1, that value is bigger than 0.05. Okay? So in this case here, it is not wrong for the share value of 20% to happen in this particular situation. Okay, so do be familiar with that binomial PDF function on your graphing calculator and use that to its advantage. And that will conclude this particular section on binomial probability distributions.